Welcome to another video as part of the Pavilion video series. Pavilion Value Proposition, enabling massive performance for block and file for NVIDIA environments. I am Kostas Apopoulos, the Chief Field Technology Officer and Worldwide Vice President of Business Development for Pavilion Data. In this video, I'm going to share some testing results and key value proposition that Pavilion has as it relates to NVIDIA-based solutions. So let's start with some great visibility we got at the Supercomputer Show in 2020 with Michael Kagan, the CTO of NVIDIA. He presented some of the results that Pavilion had as part of GPUDirect testing. I took some quotes in his general presentation and related them to how it applies to Pavilion. High performance computing requires high performance I/O. Checkbox for Pavilion. The rule is simple. The higher processing power of the computer element, the more data it can process, hence faster data delivery is required. Again, checkmark Pavilion. In particular, he talked about Pavilion. Performance improvement for file storage of almost 4 times by using GPUDirect storage. That's exactly Pavilion. And the last thing he talked as it related to storage was storage access is yet another bottleneck that needs to be resolved. Well, not with Pavilion. We deliver incredible performance to NVIDIA solutions for block or file. So NVIDIA plus Pavilion really is the complete solution for a data center. As it relates to the NVIDIA DGX A100, relative to the Pavilion hyper-parallel data platform, what is synergistic about what each of us deliver? Well, first, let's start with the DGX A100. Unprecedented compute density, performance, flexibility in the world's first 5 petaflops AI system. Well, Pavilion matches that with unrivaled performance density, scalability, and flexibility with up to 120 gigabytes a second from each array. Well, let's look in the sub-items of that. Is the DGX A100 creates better models faster and unmatched performance and enables more iterations. Well, what can Pavilion deliver and help in that space? We can deliver data faster to accelerate model training and inference and to analyze larger data sets. One other thing the NVIDIA can do is achieves the highest compute density and performance in the smallest footprint. We'll match that with Pavilion. Achieve the highest performance density and lowest latency in the smallest footprint with unlimited scale. The DGX. Accelerate development cycle from concept to production. We eliminate the I/O bottleneck to achieve results faster across every workload. So the DGX A100 and the Pavilion platform are very synergistic in delivery to the solutions to the market and that complete data center solution. So we look at Pavilion's advantages. What do we do to help unlock the storage bottleneck and unleash the beast of a DGX A100? Remember Michael Kagan's quote said, storage access is yet another bottleneck that needs to be resolved. And I said that check mark next to Pavilion. Well, how do we do that? And what is our value in the NVIDIA environment? The first is that density and performance, 4 rack units and up to 2 petabytes of usable capacity. Match that to super high performance, but ultra low latency, impressive read performance, but equally impressive write performance, which isn't normal in storage solutions. And we have NVIDIA validated performance numbers. We support GPUDirect storage for both file and block, one of the only vendors in the world that can do both. We're the only vendor in the world that can do both on the exact same platform. We support block, file, and object in general. We are open standards based, Ethernet or InfiniBand, no host agents required. We support lots of protocols that are just native to the ecosystem of Linux and Windows environments. Our performance is similar to the internal SSDs. We can enable NVMe-over-Fabrics and RDMA technologies, enable the ability to access storage and basically give unlimited storage to every single DGX. We have high-speed Ethernet and or InfiniBand connections. So we really can help unleash the beast of the power of that DGX A100, or to be fair, any other GPU-enabled server. So the key for Pavilion, again, is that flexibility. And especially for NVIDIA, we can deliver block or file. So from a file perspective, we can actually share storage between DGXs leveraging a global namespace. In some use cases, in an AI environment or in a compute-intensive GPU environment, all those DGX want to share the same files and share the same workload. We can deliver that through our global namespace of PHFS. We can do it NFS-based GPUDirect storage capable. We can share the file system between multiple DGX systems and scale storage via PHFS namespace to a massive DGX cluster. We also do that in block. And what's the value of block in a DGX environment? Well, it's a different use case. Some people have a bunch of DGX servers today that have storage inside them. They do their workload, they cluster them together, but they really don't share storage. Well, we can provide the ability to leverage shared storage from a block perspective to give every one of those DGXs more capacity than what is capable in their 8 internal drives. So we can either give those DGXs more capacity because their issue is they need more capacity because, again, they're limited to 8 drives. Or in some cases, we've seen that our performance of having the storage outside into the Pavilion box, especially in our write performance, can give similar or even better performance than those drives that are physically in the DGX. And one of the key values of that is because of the concept of NUMA zones and the issues of paths from the drives to the 8 different DGX GPUs that are in each one. So whether it's block or whether it's file, Pavilion provides the flexibility for shared storage or dedicated shared storage to each DGX. Well, let's look at performance in the NVIDIA environment. Remember, we'll start with our performance numbers in general, and I'll relate that to the DGX specific testing we did for NVIDIA. Again, in those 4 rack units, the 2 petabytes, 2.2 petabytes raw, 20 million IOPS, 3,200 watts, 20 controllers, 4,000 gig Ethernet ports. The column to the right is the per rack unit dollar or amounts. As we look at the support for multiple storage types, block, file, and object, and multiple protocols, best in every class performance. Here's our general performance numbers. Block, 120 read, 20 million IOPS, 100 microseconds, 90 gigabytes a second write, 5 million IOPS, 25 microseconds. Change gears to file, 90 gigabytes read, 56 gigabytes write, 80 gigabytes read, 35 gigabytes write. As we look at that flexibility and that performance density, again, all at market competitive pricing. You're not paying a huge premium for this incredible performance. In our testing, in the NVIDIA GPUDirect environment, remember addressing that issue that Kagan said, high performance compute requires high performance IO? When we did our GPUDirect testing, GPUDirect storage for block, leveraging 2 Pavilion hyperparallel flash arrays, we delivered 182 gigabytes a second read at 3.87 milliseconds latency and 149 gigabytes a second write at 4.51 milliseconds latency. Now keep in mind, that's using not an FIO, it's using something called GDSIO, which is way more of a data path. We're taking the data all the way up and loading all 8 GPUs. Thus, the latency is higher than just a pure simple IO to a CPU. The next piece is with file. We delivered 191 gigabytes a second at 1.7 millisecond read and 118 gigabytes a second at 5.6 millisecond write. Again, leveraging 2 Pavilion platforms to be able to saturate, 100% saturate a DGX. If we drill into those numbers, the numbers on the left are file, the numbers on the right are block as it relates to our GPUDirect storage testing. What this test is to show what is the value of a GPUDirect, which bypasses the CPU to load the GPUs, to regular IO, which means the flow goes to the CPU and the CPU loads every one of the GPUs. If we look on the left, which is file, first set of columns are read, the second columns are write. The blue is leveraging GPUDirect storage. The orange is non-GPUDirect storage, which is not different storage. It's a protocol change. In the world of NVIDIA, they typically talk GIB per second, which is in the bold and black. I'm going to throw out the numbers in the gray below that, which is gigabytes per second, which where most storage people think of. Again, in the file world, we delivered 191 gigabytes a second for read using GPUDirect protocol. Without GPUDirect, it was 75 gigabytes a second. 118 for write, 74 for write for non-GPUDirect. Now what's important to look at is the yellow numbers inside each one of those columns. That is the CPU utilization. So if you think about that, we delivered 191 gigabytes a second read for file, and it leveraged 16% of the CPU when using GPUDirect storage. When using non-GPUDirect, we delivered less than half of the performance at double the CPU utilization. Again, that has nothing to do with Pavilion's capability. It says everything it does to get the data physically once it enters the DGX, leveraging through the CPU and load all the GPUs, or leverage it direct to the GPUs. Same test for block. You can read the numbers on the right. Everything I said is the same. Numbers are different. Philosophies are the same. So the value of Pavilion here is our 8 rack units, because we used 2 units to deliver this test, was to saturate a DGX. So 4 rack units per chassis. But the key is our ultra low latency, our impressive write performance, and no host agents required. All these are the values, some of the values which NVIDIA sees and NVIDIA customers see. You can read the notes for some different characteristics that qualify the tests. As we look at that, how does those numbers compare to the competition? Well, the legend here is the purple numbers on the left are VAST, the black numbers on the right are WECA. These are all numbers that are published in various blogs and testing results, either on WECA and VAST websites or NVIDIA blogs. As it relates to read bandwidth, we were we'll look at VAST first. We were 110% their read bandwidth, 9% their latency, at less than half their rack units. We were almost 400% their write bandwidth at 47% their latency. Again, same test for VAST and us is put enough equipment to saturate a single DGX A100 and its 8 GPUs. WECA, the numbers on the right, was 117 compared to us. We were 117 compared to WECA. We were 73% their latency, 73% their rack units, and 169% their write bandwidth. They didn't publish their write latency. Neither VAST nor WECA can do block storage, so they can only do one use case with NVIDIA. Here's the data charted, so you can see the same information I shared on the previous slide. The key differentiation for Pavilion is we support block and file. VAST and WECA don't. Impressive read. They do pretty good in read by putting enough hardware to it, but our write performance is materially better. We have much better latency, and we have much smaller rack units in the test. So what does all that performance do for a DGX A100 that can be delivered by a Pavilion storage platform? Well, we had a potential partner, OmniSci, get asked by one of their customers, what could their performance be and do leveraging a platform like Pavilion? They had challenges in general that said, we needed to do more analysis than what the data is allowed to be on an individual DGX A100. They were limited to the capacity of the 8 drives that were in the DGX A100. In their use case, they were doing analysis of a particular, it's a classified particular concept, and they could only do analysis for 60 days because that's how much data would apply in there. They wanted to be able to do analysis for a year, 2 years, 20 years of data, but it was limited to the capacity that was physically in those drives. These were multiple DGXs, by the way. So we did testing with them, and we tested the OmniSci database, which is an in-memory GPU database. We tested it with their storage being inside the DGX. And when we did their testing, they got performance X. The performance number is immaterial, right? It was just performance X. And then they were limited by the capacity that was in the NVMe drives. Remember, in this scenario, their issue was they needed access to more data. Well, then we tested that with that same database and same application data physically on the Pavilion platform, leveraging NVMe-over-Fabrics RoCE. So when they did that testing, they got performance X, the same performance as it was with the drives physically inside the DGX. Well, what did that get them? Solved their problem. They effectively have unlimited capacity because they can keep adding LUNs and keep adding block storage to every one of those DGXs until whatever capacity they need. So again, the use case was do analysis on 30 to 60 days worth of data and wanting to do that on 1 year, 2 years, 20 years, 30 years of data. Pavilion gave them that capability. Similar to the same performance as the drives, the system with the drives physically inside the DGX A100. We moved it out on the Pavilion and we got similar or same performance as the information physically inside the DGX. So to sum it all up, let's give the slide I gave earlier where we were addressing Michael Kagan's comment, storage access is yet another bottleneck that needs to be resolved. Remember, the key value proposition of Pavilion and NVIDIA environments is our density, 4 rack units up to 2 petabytes usable, super high performance for both read and write, all numbers validated by NVIDIA. We support for GPUDirect storage and storage access in general, file and block in particular for GPUDirect storage. We support the protocols block, file, and object, giving the customer the most flexibility. We're open standards based, Ethernet or InfiniBand, no host agents required. And we've shown that we deliver similar or same performance to their applications as the data physically in the DGX versus outside in unlimited capacity from a Pavilion storage array. So the ultimate in flexibility for NVIDIA, whether that's block or whether it's file, whether it's high performance requirements or because you need more capacity, Pavilion delivers. Thank you for watching this video as part of the Pavilion video series. If you want to learn more about this topic or others, check out our other videos at www.pavilion.io. You can also reach out to us via email at info@pavilion.io, or you can always call us on the phone. We'd love to talk to you about how Pavilion can help you solve some of your most challenging storage-related problems and help you deliver incredible business outcomes to your customers. Thank you.